Let's start it off. So we have 8.4 solve factored polynomials. There should also be a comma factoring. So there's like two parts to this section. We're going to do both today. Now we're going to first talk about the zero product property. It's a very important property that has to do with a lot of math. And it's kind of straightforward. So let's try to discover it together. So this is called the zero product property. All right. A times B equals 0. If A times B equals 0, anyone can unmute. What does one of either A or B have to be?
0.
0. Now, here's what's interesting. You could have a situation. So if A times B equals 0, then, let me type this out so it's clear. Then A or B can or is 0. Now that's kind of interesting. You have a situation where you technically have two possible answers, where A is 0 or B is 0. So what does that mean? Let's say we have a situation like this. X times X plus 3. I'll put this in parentheses to indicate it's its own thing. So X times X plus 3 equals 0. Since this is some entity, we could call that A if you want, and this is some other entity, we could call that B if you want. That means A or B is 0, which means what letters can I, or what numbers can I plug into the X to cause this to be 0? You could try to use a little mental math. What X values could I plug into here to cause the whole thing to be 0? Okay.
0.
0 is one of them. Good. If I plug in a 0 into this one, it would cause the whole thing to be 0. Does anyone have another possible one?
If the other X is 0, that's really
Good. So here you said X plus 0. But the thing is, if I plug in a 0 here, that would be 0 plus 3. That causes to be 3. So what can I
would
do
that
to...
be 1?
Did I hear a 1?
Yeah.
If I plug in a 1, this would be 1, and this would be 1 plus 3, which is 4. So that doesn't cause it to be 0.
What about a -3?
Ooh, so somebody said it correctly. Good. What if I plug in a -3? What I would get is -3 times -3 plus 3. But what's -3 plus 3? 0. So -3 times 0 gives me 0. So your two answers, and I said it, you have two answers in this case, is 0 and -3. Why is it two answers? Because if you plug in a 0 in this equation, you would get 0. If you plugged in a -3 in this equation, you would get a 0. So the numbers that cause it to be 0 are your answers. So you would write X equals 0, comma, -3. Very important. Go ahead, what's up?
I don't get the 0 part.
If I plugged in 0 into this part, I'll do it in red. So it's 0.
Yeah, but if you have to plug it into the other one.
Yeah, that's okay. Because if this is 0, it's going to be times 0 plus 3, which is 3, which still causes it to be 0.
Oh.
Yeah, remember, it's A or B. Or in other words, we don't really care if both of them are 0. We just want one of them to be 0 at a time. So that's why you get two answers here. Now let's do the other one in a proper format, not like in a mental math style. So let's say x plus 3, or let's change the number. Let's do x minus 2, and let's do 2x plus 1. Of course, this equals 0. Very important, it has to equal 0 for this to work, or you can't do this. Now, if I were to write out steps, which I usually don't, but today will be useful. Your first step would be to set each multiple to 0. Now, what do I mean by set each multiple to 0? You know what? I'll give you like 15 seconds to copy. I just realized I disrupted stuff. 15 seconds to copy on this. X minus 2 and x plus 2x plus 1 equals 0. Okay. So first step would be set each multiple to 0. This is one multiple, x minus 2. This is another multiple, x2 plus 1. You can also say factor, each factor to 0. Which means I'm going to split this up and set it as two separate problems. X minus 2 equals 0, and 2x plus 1 equals 0. So what I did is I split everything that's being multiplied and set it equal to 0. And then step 2 is very straightforward. Solve for each. So what we're doing with this kind of situation, which is solving a factor, a polynomial, is we're breaking it into smaller pieces and solving each one at a time. So over here on the left, I would do plus 2 plus 2. That means x equals 2 in this case. Over here on the right, I have to do a little bit of algebra. Minus 1, minus 1. So I have 2x equals negative 1. Divided by 2, divided by 2. X equals negative a half. Okay. So you got x equals 2, x equals negative a half. Those are your two answers. X equals 2 and x equals negative a half. Now I'm going to check it. You do not need to check it every time, but I'll just do a check to prove it. So here's the x equals 2 check. So I'm going to plug in every x's with a 2. Well, actually, let me invert the colors. So then 2 times plus 1 equals 0. Okay. Let me move it here so we have space. Let me move it here so we have space.
What does x equal on that?
Hold up. I'll show you. I'm just trying to. No. To the left. Okay. So let's talk about the first one. Let's plug in x equals negative 2. So negative 2 would be for this x, and the negative 2 would be for this x. So I'm sorry, it was a positive 2. So it's just, oopsies, x equals positive 2. So this would be a positive 2, this would be a positive 2. So I plug in every x becomes a positive 2. So this will be 2 minus 2, 0. And this would be 2 times 2, which is 4, plus 1 would be 5. But doesn't matter because 0 times 5 equals 0. So x equal 2 checks off. The second one I'll plug in, x equals -1/2. So
What was the original equation?
the original equation was this one, x minus 2, 2x plus 1 equals 0.
How does 5 equal 0 though?
Because what's 5 times 1?
Oh. But didn't you just say that x equals 2 and x equals 1/2?
Yeah, I'm just showing the check as improving it. You don't have to check it. I would not recommend even checking it because this is a very straightforward solutions. So no real need to check it. I'm just showing you like proof that causes this. You don't need to prove it every time. On the left, -1/2 minus 2 will be -2.5. If you turn that into an improper fraction, that would be -5/2. Over here, 2 times -1/2 will be -1, and -1 plus 1 equals 0. And then 0 times negative whatever is going to be 0. So this works out also. Now, do you need to check / prove every time? No. In this situation, you will always get the right answer as long as you follow steps, which is break it up and then solve. Anyone has any particular questions? Okay.
Wait, Mr. Global.
What's up?
You seem like the type that watches basketball.
For the thing, like what is this part you just did for us? What is this?
Why is
Okay. This right here is the only thing I actually want you to do for the problem. This right here would be like a teacher showing you why it's true or false. I'm just proving it. You don't need to do that. Go ahead, Shro.
What's the answer?
The answers is x equals 2 and x equals a -1/2. Those are your two answers. Now, everyone, try for number 1 and number 2 yourselves. I'll give 3 minutes. Remember to split, then set up. So split and set up. One more minute.
Less than 2 dozen.
All right, minute passed. Okay. So for your first one, you should have got x equals -3. You would subtract 3 on both sides. And x equals +5. You would add 5 to both sides. Here on the bottom, you should get x equals 5/2. You might have wrote it as 2.5. You might have also wrote it as 2.5. Either answer is correct. I'm sorry, it should be negative of all these. Negative 5/2, negative 2.5, negative 2.5. Over here, this would be a positive 1/3. It'll be on negative. Okay. Does anyone have any questions on that? Those are the answers. So does anyone have any questions?
You did.
Well, I
If you
got
did your
2/5.
research.
2/5? No, because it would be 2x.
5/2. 5/2.
His mom's name is.
That's
Wait,
correct then. 5/2 is correct. 2/5 is not correct. Okay, so that's the zero product property. Very important. You'll see we'll use it all the way through this chapter. Let's talk about the next thing. Factoring. You just could write factoring. You don't have to write this, but kind of like that. I'll just make that smaller because it's not that important. But factoring is the title. Now, just write the word factoring. If A times B plus C, what can I do with that A into the B and C? What can I do? Anyone could speak up on this. What can I do with that A? I could distribute. So this will become AB plus AC. Okay. If that, then that. That's distribution. Yeah. So what we're going to talk about today is factoring, which is kind of reverse. If there's some situation where you have AB plus AC, then you can, instead of multiplying in, you're going to do the opposite. What would be the opposite of multiplying in?
Multiplying out.
Not multiplying out,
Dividing out.
dividing out. So we're going to divide out the A, B plus C. So we take out, divide out the B plus C, and this is factoring. Now, the first one I'm going to show you is with normal numbers. In this situation, you would never really factor normal numbers like this, but it shows a concept that we could definitely agree that is true. So our first example is going to be with normal numbers. Let's say I had 15 plus 9. Now, everyone here should know that equals 24. Everyone would agree with that. But that's not what I want to talk about today. What is in common between 15 and 9? Or in other words, what is each have a common factor between 15 and 9?
They're both odd numbers.
3. No, they're both odd numbers, but particularly they're divisible by 3. So what I can do is divide out. I can divide out both of them with a 3 and put it in front. So I would get 3 parentheses, 15 divided by 3 is 5, and 9 divided by 3 is 3. Okay. So you can take out a 3. Now, let's just check that real quick. 15 plus 9, 24. 3 times 5 plus 3, that's 3 times 8. 8 times 3 is 24. So we can see with this number example, factoring it out does not change the value. So we're allowed to factor out anything we want as long as it doesn't change the value, which is important. Now, you wouldn't do that with numbers. You would just add 15 plus 9. That doesn't make sense to do with numbers, but sometimes we have awkward situations where we have variables dealing with it. So let's talk about that. Let's go 4x to the second power plus 10x. Let's say equals, let's not equal 0. Let's just say this for now. So we got 4x to the second power plus 10x. Now, my issue is, and I'm going to go back to the previous page, when I'm dealing with like splitting it into equals 0, there being multiples, but I only have a single x. Here, I have to figure out what I need to plug in to cause this to be 0. Now, somebody smart enough will say 0, which is true, but I need to figure out every possible number I could plug in there. And I need a way to do it every time without guessing and checking every number in the universe. So I'm going to factor out anything that's in common between here. First, let's talk about the numbers. What is in common between the 4 and the 10? 2. So we're going to factor out a 2. So that's going to leave. Next, what's in common between x squared and an x? You have 2 x's here. You have 1 x here, which means you have 1 x in common. Because you have 1 x in common, you're going to factor out an x. If you ever did greatest common factors, like back in fractions, this should be familiar. Maybe not the variable aspect of it, but greatest common factor, this is the same concept. So I'm taking out the 2x because that's what's in common between both of them. And sometimes the hardest part for people is just figure out what's in common. Now, 4x squared divided by 2x. This goes to the exponent rules on our last test. So 4 divided by 2 is just 2. And x squared divided by x, that's x to the second divided by x to the first. So you subtract, that's going to be x to the 1. These matching is coincidence. That doesn't always happen. This one, 10 divided by 2. 10 divided by 2 is 5. X to the 1 divided by x to the 1. You subtract the exponents. That becomes 0. So you don't need to write any x's. So it's just 5. So what we have here is a completely factored out expression. This skill of factoring is not easy nor very straightforward. Unlike the last 3 sections, which I think were kind of like you just multiply, you just add, you subtract, you just follow the steps. Here, it's a lot on you figuring out, oh, what is in common? So there's a lot of mental work on that sense. Okay. Let's go to the two examples. How many examples I have actually? Probably we'll save that for tomorrow. So let's go to the two examples here. I'm going to work at least the first one with you because it's something unique. Second one, I'll make your like exit ticket-esque thing. So the first one, we got 8x plus 12y, y. And the instruction says factor. So first, I'll look at the numbers, 8 and 12. What's in common between 8 and 12 is a 4. So I'm going to factor out a 4. Now, this is an x, this is a y. They don't have an x in common, so I cannot factor an x. They don't have a y in common, so I cannot factor a y. Which means if I take this out, it will be 4. What's left inside? 8 divided by 4, 2x. 12 divided by 4, 3y.
Wait, is the 4 on the outside because of the factoring?
Absolutely. The 4 is on the outside because of the factor. You take the factors on the outside. Again, it's the opposite of distribution. So distribution, you multiply in. Division, or factoring, you divide out. So you got to think of it in reverse. So it's just 4, 2x plus 3y. You can't do anything beyond that. Everyone who has a Zoom, try to do your number 2. I'll count that as your exit ticket. So try that as your best. If you don't get it, I'll still go over it, especially for the recording, so you can check it out later. Noah, great job. You're free to go. Have a wonderful day.
Thank you.
Sherelle, you took out the right number. You need to take out the y's also. Rachel, you took out too many y's out of one of those numbers. You took out too many y's. It shouldn't be just 2 plus 3. Tara, great job. You're free to go.
Thank you.
So would it be 5y to the second?
5, did you say? I don't see why a 5 would be. Rachel, you're good to go.
I took out too many
Whatever Cheryl puts in the chat, I agree with her. So like she'll put my name, like I'm with. Okay, bye.
I got you. I
Wait,
understand what you're
Mr.
saying.
What do you
Oh,
mean
wait,
too many y?
You have y in the
I'm
second
back
and
on
the
my-
first one. Galit, you're good. You have y in the second and the first one, and y in the third and the y in the first and the second one. So you have to take out y in common. Yabby, you reduced it correctly. No, you didn't reduce. You reduced the numbers correctly. The number you
what would it
divided should go to the front.
I'm saying, so what should I take out?
A y. Jessley,
I get
you
it
got
right.
Daniela, you
Why should I
got it.
take out? So it'd be like 2y to the second plus 3?
Guys, I have to go.
You'll see.
Everyone.
Yarnin, I don't understand what you're exactly saying. So if you match what I said, then let's see. Here in this situation, you got to take out what's in common. First off, most people got 7, which is good. The other thing you have to take out of common is a y. So 7y must be on the outside. And what's left over will be 2y plus 3. That's what's going to be left over. So make sure you.
Why is it gonna be?
Mr. Toba, I was with Craig, Kobe Brand, and Michael Shankman.
Yeah, just type it in. Type in the name so I know. And Sherelle, what was your question?
Why is it 7y?
So 7, because 14 and 21 has a 7 greatest common factor. You agreed with that because you knew it was 7. Now
Why is it
why
like 7?
y? Yeah. y squared and y. So the first one has 2 y's, the second one has 1 y. How many fingers does it have up in common? It has 1 finger in common. So that means the greatest common factor in the variable sense is 1.
Okay. Thank you.
Okay.
Have a good day.
No problem.